in today's session, what we'll be doing essentially would be we'll identify the unique vocabulary associated with thermodynamics, and we'll use that vocabulary to define the basic principles that govern thermodynamics. That is the first thing. And essentially, we'll be focusing on that in today's class. Then, within this chapter, you will be within this chapter, you will be focusing on SI units and the English unit systems. Few of the conversions that you should know. You should memorize those conversions, and the reason why you should know those conversions, which would be followed by some of the essential concepts of thermodynamics, which includes system, state postulate, equilibrium, process, and cycles. These basic terminologies would be with you throughout your thermodynamics. Clear? So you should have a clear understanding of these terminologies. And at the last, we'll have a revision of the concepts with regards to temperature scales, pressure, absolute pressure, gauge pressure. Some of these concepts would also be incorporated in your fluid mechanics, but you need to have an understanding of these concepts. This would comprise all that you cover that you will be covering in your chapter 1. Clear enough? All right. जी
Yes.
सवाल है कोई? Abdullah.
No, sir.
All right. But again, have your mask properly on. So moving on to the definition of thermodynamics. Thermodynamics is basically the science of energy. What do you mean by the term science? Sorry?
Understanding concept building.
Understanding. Science is understanding. Knowledge obtained by observation. Study. Anyone else? Science is basically knowledge collected within a domain. That means whatever there exists with regards to energy, that is incorporated into a single body, which is known as thermodynamics. Everything that has to be dealt in terms of energy is basically uh, uh, encompassed within the domain of thermodynamics. So it's a body of knowledge which includes everything that has to deal with energy. If this is thermodynamics, then what is energy? Ability to do work, just work. Energy is basically ability to cause a change. All right. So any change is basically in terms of energy is basically caused by energy transformations. For example, if I have a stone at this height and it has certain amount of potential energy, all right. Why do I say potential? Due to its ability to transform into kinetic energy as soon as I drop this stone. So it is the ability to transform from one form to another. Clear? What is the principle of conservation of energy? Or what is the first law of thermodynamics? Agreed. So it says that energy can neither be created nor be destroyed. It can only transform from one form to another. Clear? Before that, thermodynamics is basically comprised of two words, which is thermi and thermodynamics. Thermi means heat, dynamic means power. Essentially, it was basically uh, if you recall the first ever real time application of thermodynamics, which is the steam engines, there was thermal energy available which was used to transform into power. Clear? That laid the foundation of thermodynamics in 1960s and 70s. But today, all sort of energy interactions, whether it is with regards to heat, whether it is with regards to whether it is with regards to mass coming into a system or going out of a system, all are attributed towards thermodynamics. Clear? So it's a broader terminology now, which incorporates all sorts of interactions taking place with regards to energy. Clear? Again, moving on to the first law, which is the conservation of energy, principle of conservation of energy, which states that energy can neither be created nor be destroyed, but it can change its form, as it is shown on the figure to the right. That potential energy at a certain height gets transformed into kinetic energy as the stone is being released from a certain height, and all of the potential energy essentially converts into kinetic energy just before the stone hits the ground. That gives me an idea that energy has something to do with the quantity. Is it? So the first law is basically dealing with quantities, and that is being emphasized in all the three bullet points. But let's say I have a hot cup of coffee with me. I bring it into the class. What would happen to that cup of coffee after a certain time?
It would reach room temperature.
It would attain room temperature, it would cool down. That means there is certain quantity of energy available within that cup that gets transferred from the cup to the surroundings. So one thing is for sure, that there is certain amount of quantity that is getting transferred. Clear? Now, why it doesn't happen that the same amount of energy which is present in the surroundings transfer from the surroundings towards the cup? एनर्जी की क्वांटिटी तो उतनी ही है, पहले वो कप के अंदर मौजूद थी, अब वो सराउंडिंग में मौजूद है. Why doesn't it happens that the same amount of quantity of energy which is available in the surrounding gets transferred other way around? क्यों नहीं होता ऐसे?
सर एनर्जी जो है वो हॉट रिजर्वायर से कोल्ड रिजर्वायर की तरफ फ्लो करती है.
All right, I have one answer, that energy transfers from hot reservoir towards cold reservoir.
सर एक और चीज भी है
जी बोलिए.
कि अगर इसको माइक्रो स्केल पे देखें तो जो टेम्परेचर जो ट्रांसफर हो रहा है, जो हीट ट्रांसफर हो रही है, वो मोशन ही है. तो जो सराउंडिंग के पार्टिकल्स हैं उनकी मूवमेंट कम है, और जो कप ऑफ कॉफी है उसकी मूवमेंट ज्यादा है. तो आपस में जब वो इंटरेक्ट करेंगे तो ये अपना मोशन उनको ट्रांसफर ही करेगा ना सिर्फ.
Essentially, you are saying that energy of the particles having higher momentum gets transferred to the energy where the momentum of particles is much less. This is
लोअर.
what you're trying to say.
यस.
Yes. अच्छा ठीक हो गया. High energy level to low energy level. We have already defined there is some quantity involved. Now, the principle of the second law says that energy gets transferred in the decreasing direction of quality. अभी तक हम सारी बात जो कर रहे थे वो क्वांटिटी की कर रहे थे. सेकंड लॉ ये कहता है कि सिर्फ क्वांटिटी काफी नहीं है. There is another term which is quality, which is essential to define, which governs this process, which means that the same amount of energy, if present at a higher temperature, would have essentially a higher quality. Clear? उतनी ही अमाउंट ऑफ एनर्जी अगर किसी हायर टेम्परेचर पे मौजूद है तो उसकी क्वालिटी ज्यादा होगी एज कंपेयर टू at a lower temperature. Is it clear? And the second law says that energy would always transfer in a form such that the quality of energy decreases. हायर टेम्परेचर पे ज्यादा क्वालिटी है, लोअर टेम्परेचर पे कम क्वालिटी है, और ट्रांसफर जब भी होगा क्वालिटी डिक्रीज होगी. क्लियर? So this is essentially the second law, which says that energy has quality as well as quantity, and actual process occurs in the direction of decreasing quality of energy. प्रोसेस के लिए सिर्फ एनर्जी का अवेलेबल होना जरूरी नहीं है, उसके साथ साथ उस प्रोसेस में एनर्जी की क्वालिटी का डिक्रीज होना जरूरी है. क्लियर? Alright. Now there are two approaches that will be that are normally used to study thermodynamics. One is the classical approach of thermodynamics, and one is the statistical approach. Classical approach, which is also known as the macroscopic approach. In that approach, I'm not concerned about the characteristics of individual particles. For example, I want to know what is the pressure within this room. I'll simply insert a pressure gauge outside the room, जो कि मुझे इस रूम का प्रेशर बता देगी. क्लियर है ये चीज? मुझे ये इससे, और and if you want to know what is the physics behind the pressure that is being created within this room, it is the momentum of the particles which are constantly colliding with the walls of the room that creates the pressure. Clear है ये चीज? So I am not concerned about the point कि रूम के इस हिस्से में जो particles हैं उनका momentum क्या है, and the ones which are close to the door उनका momentum क्या है. Individual particles के behavior के बारे में information होना, excessive information तो हो सकता है, लेकिन it is not essentially useful to me. Clear? Similarly, if I have to compare this class with another class, the average GPA of this class, if let's say is 3 or 3.2, compared to some other class which is 2.8, I would have a fair idea कि ये class कैसी है as compared to the other class. I need not to have the information regarding how many students have A grades, how many have B plus, B. That might be the excessive information which may not be required for my purpose. Clear? So the approach that we'll be following is the macroscopic approach. We'll be looking at the characteristics of the system macroscopically. Will not be involved or will not be interested in statistical thermodynamics, where the behavior of a group of particles is being studied. Clear? Moving on, the applications of thermodynamics, just to give you an idea how closely you are related to thermodynamics. You pick up any device, any component in your house, be it a refrigerator, a geyser, a microwave oven, a TV, a computer, a laptop, a light bulb. Everywhere energy interactions are taking place. Clear? From that minute scale to an enormous global scale where you have power plants running, where you have jet engines, where you have nuclear vessels. So everywhere you have involvement of thermodynamics, because energy interactions are taking place within your daily life and outside your daily life. So the horizon of thermodynamics, or the scope of thermodynamics, is immense. Clear? The common example. Have you ever heard कि heart patients को normally recommend किया जाता है कि just after they have taken their food, they should not do any exertion. सुना है कभी? क्यों? Actually, when you have taken your food, the work that heart has to perform increases. Pumping increase हो जाती है. It is basically transferring energy to thousands of cells within your body, which essentially generates energy. It is basically based on this principle, the energy is generated within your body. And if you realize, why are you wearing a jacket today? Sorry. अच्छा इसलिए पहनी थी छोड़ो. प्रेस नहीं थी शर्ट इसलिए पहन ली. कभी ऐसा भी हुआ कि ठंड लगी हो तो पहन ली हो जैकेट? ऐसा भी कभी हुआ होगा जिंदगी में. So what is it that you're trying to contain? The heat which is produced within your body. Now, there are two options. Whether you let it go out of your body. Your body is essentially a system. इसमें heat generate हो रही है, and you are adjusting your clothes with regards to the energy that you would like to have. Clear? आप में से बहुत से लोगों के घर में एसी लगे हुए होंगे. ऐसे ही है. एक कमरे में लेट्स से 12 बाय 12 फीट का एक कमरा है, उसमें कितने एसी काफी होंगे? 4 एसी लगा लूंगा, ज्यादा ठंड नहीं हो जाएगी? क्यों नहीं लगाते 4 एसी? दैट्स व्हाट थर्मोडायनामिक्स ब्रिंग्स यू एट द एंड. ये एक एसेंशियल पॉइंट है जिसकी वजह से थर्मोडायनामिक्स को पढ़ा जाता है. इकोनॉमी, हाउ टू मेक योर सिस्टम एफिशिएंट. गाड़ी खरीदने जाते हो, क्या चीज देखते हो? माइलेज कितनी है, फ्यूल कितना कंज्यूम करती है. व्हाई? बिकॉज एवरीथिंग कम्स बैक टू द इकोनॉमी. आपका सिस्टम कितना एफिशिएंट है. सो essentially the motive around studying thermodynamics is making system efficient. In your laptops you have these fans, cooling fans. ये क्यों नहीं होता कि जब आप लैपटॉप खरीदने जाते हो साथ एक पेडेस्टल फैन भी दे दें आपको, साथ लगा के घूमो, अच्छी तरह ठंडा रखेगा? सॉरी, बिकॉज इट इज बियॉन्ड द नीड. जितनी हीट जनरेट हो रही है उसके लिए पेडेस्टल फैन नहीं होना चाहिए, उसके लिए उसी कैपेसिटी का फैन होना चाहिए जो कि आपके लैपटॉप के अंदर ऑलरेडी फिक्स्ड है. क्लियर? हाउ डू यू फाइंड आउट कि व्हाट इज द राइट कैपेसिटी? इट इज बेस्ड ऑन थर्मोडायनामिक्स, द प्रिंसिपल्स ऑफ थर्मोडायनामिक्स which helps you in calculating the right amount of wattage for the fan that is being installed in the system. Clear? All right. So I'll stop over here.